Welcome to Unit 2, all about quadratics. And before we start graphing quadratics and manipulating them and solving them and all that good stuff, we need to talk a little bit more in depth about transformations. Okay, so there's, I would say, three big transformations that you're going to see. Okay, the first is reflection. So you're either going to have a vertical or a horizontal reflection. And here's how we address it. If you are a vertical reflection, you are flipping over the x-axis. So ultimately, you're flipping upside down over the x-axis. We saw this with both absolute value functions and the greatest integer. Okay, and a side note, as I am going through and writing things down and speaking, please write down additional notes. Even if I don't write it, that doesn't mean you shouldn't, okay? So vertical reflection is flipping over the x-axis, and how do we see it? It's when there is a negative in front of the a value. That means that there is a vertical reflection. Now, if there's a horizontal reflection, we are reflecting or flipping over the y-axis. In essence, we are turning around on ourselves. So graphs that are symmetrical, like the absolute value function, when it has a horizontal reflection, we can't see it. We can see it in the equation, but graphically it looks exactly the same because it's a symmetrical function. This affects the b value. So if there is a negative in front of the b value, we have a horizontal reflection. Okay, so the first type of transformation we might see is a reflection. The second is a stretch or compression. So how do we know, pardon me, if it's a stretch or a compression? Looking at the vertical, okay, so if I'm a vertical stretch or a vertical compression, if your a value is greater than 1, you are a vertical stretch. Ultimately, what this looks like is your graph is getting skinnier. Is that a mathematical term? Absolutely not. But it helps us to be able to see or think about what this does to our function. If there is an a value that is between 0 and 1, so a proper fraction, not an improper. If you have an improper fraction like 3/2, that's 1.5. That is greater than 1. So if you have a proper fraction, we say that it is a vertical compression. And it's important to note that it's greater than 0, because if it's 0, the entire equation goes away. 0 times anything is 0. So we don't want it to be 0. And we don't ever address the a value as negative. If there is a negative on that a value, then it's a reflection, okay? So if it is between 0 and 1, it is a compression, which means it is getting wider, whatever our function may be. For us, that on the greatest integer function, that meant that our steps were getting wider or shorter. Now, if it's, the steps, the distance between the steps. There we go. Get it together, Patterson. All right, looking at the horizontal, anything horizontal affects the x, right? So if my reciprocal of b is greater than 1, because remember, it's in the given equation. So you can think of it if the reciprocal is greater than 1, or if the given value is between 0 and 1. Between 0 and 1. Because if I'm a proper fraction, let's say 1/2. Okay, in the equation it says 1/2. Its reciprocal is 2, and 2 is greater than 1. Therefore, it is a horizontal stretch. You can think of it either way, okay? If I'm horizontally stretching something, I am getting wider. And if the reciprocal of b is between 0 and 1, or the b value in the equation is greater than 1, we say that it is a horizontal compression. And this causes the function to get skinnier if we're talking about a quadratic, a parabola, or if we're talking about absolute value. when we are dealing with the greatest integer function, this is what affected the step length. Okay, the third type of transformation we will see is a translation, shifting left, right, up, or down. So if I'm a vertical shift, that is the k value. We take the same sign as is written in the equation. As written in the equation. And it shifts the function. That does not look like an H. It shifts the function up or down. It affects the y values. For horizontal, that is our h value within the equation. We take the opposite sign of what is written, opposite sign as written in the equation, and you guys saw that with the greatest integer and absolute value. And that means that we are shifting left or right. We shift left or right. It is a horizontal translation. And we take the opposite sign. So, ladies and gentlemen, 3 types of transformations that we need to be able to identify and talk about. You need to be able to state the transformation language. Now, what does it do? Well, the greatest integer function is by far the best function to be able to see this. So let's take a look at its generic form. We know that the a value is the vertical stretch or compression or reflection. For a greatest integer function, that means it's going to affect the distance between the steps. And we already know this because it was in our last unit. And then the b value affects the length of this step because it's the horizontal stretch or compression, and then h and k are our translations. So here we are. We are given the fact that f of x is equal to the greatest integer of x. So we're asked to write each function below and then list the transformations and graph it. Let's do it. All right, for the first one, it says that g of x is f of x minus 5. What does that mean? It means that g of x is the greatest integer of x minus 5. Thinking back to our equation up top, x minus h, that means that I'm moving 5 units right. And let's graph it. Make it bigger. Come on, buddy. There we go. So instead of starting at 0, 0, I now start at 5, 0. 1, 2, 3, 4, 5. Close circle. Extend to the right. Open circle. Our A and our B are 1. So the step length is 1 unit. The distance between the steps is also 1 unit. And again, I ask that you try to go at least half the graph so we get a really good idea of what this function is doing and what it looks like. Okay, example number 1. The next one says g of x is f of x plus 7. So again, f of x is the greatest integer. So I'm going to substitute this in for x. I get the greatest integer of x plus 7. I have to take the opposite sign of my h value, a value inside of the brackets with x. So that means I'm going to go 7 units left. Okay, here we go. I'm going to go 1, 2, 3, 4, 5, 6, 7, close circle. I don't have any reflections, so I'm still extending to the right. A is 1, B is 1. So my step is 1 unit in length, and the distance between the steps is 1 as well. Nice. H, translation horizontally. If we look at the next one, it says f of x plus 2 on the outside. So I'm going to substitute in what the given f of x was, which is the greatest integer, And the plus 2 is on the outside, which can only mean that that's a K value. So I'm going to say that we are shifting 2 units up because K is positive 2. So instead of starting at 0, 0, I'm going to start at 0, 2. Yep, A is still 1, B is still 1, and we don't have any reflections. So the step length is 1, the distance between the steps is 1, and we're increasing from left to right. Nice. Looking at the fourth example on the top row, there we go, f of x minus 4. All right, again, f of x is defined as our greatest integer function with 4 on the outside, a negative 4. So that's our k value, and that means that we are going 4 units down because the k is negative. It's affecting my y values. So instead of starting at 0, 0, I'm going to start at 0, 1, 2, 3, 4. Again, A and B are 1, so the step length is 1 unit. The distance between the steps is 1 unit, and there aren't any reflections, so we increase from left to right. Perfect. So there's our translations, both horizontal and vertical, that we can see. The greatest integer function is by far the best function for us to see these transformations. It's not symmetrical. We've got closed and open circles, so we can see if there is some sort of a horizontal reflection. It really is nice. So let's keep going. All right, 2 times f of x. So that means it is 2 times the greatest integer of x, because that's what f of x is defined as. And 2 is on the outside of the bracket, so that is our a value. It is greater than 1, so we say that there is a vertical stretch. What does that mean to our greatest integer? We're not shifting left and right. We're not stretching our step because it's not horizontal. We are vertically jumping 2 units to get to that next step. We're stretching the distance between our steps by 2 units. And there it is. But what if, oh man, what if it's this? 1/2 times the absolute value. What? Yeah, don't make that mistake. Times the greatest integer of x. If you're thinking what I'm thinking, we're thinking this is going to get real small because 1/2 is between 0 and 1. It is a proper fraction. So it is a vertical, because it's an a value, compression due to the fact that it's between 0 and 1. Okay, so I'm going to make mine real big. I know, cheating. You don't get to. Really sorry. Can't enlarge your paper. We're still starting at 0, 0 because h and k are 0. I'm extending out 1 unit, but oh, Nelly, I'm only going up 1/2 a unit to the next step. We vertically compressed. We made the space between these steps smaller. That's what a compression is. I don't know if you have ever known anyone to wear compression socks. What they do is they apply pressure to your legs to help with your blood flow. Compression, they're compressing it. So this is a vertical compression. We're pressing down on the function. Okay, f of 2x. So that means we're taking the greatest integer of 2x. Aha, yes, this is now a b value. So in the equation, b is 2, which means that we address the reciprocal of b, means we are getting a horizontal compression. So if I horizontally compress this function, that means that I am making the step lengths shorter. Yep, here I go, zooming in. So 0, 0, we're still starting, and then I extend out 1/2. Doesn't look like it, but I promise I did. And then our a value is 1, so we go up 1 unit, extend out 1/2. Up 1 unit, extend out 1/2, and so forth. A is 1, so we go up 1 unit, but B is a half. Therefore, the length of our steps has been horizontally compressed. Whew! Little teeny tiny steps. Okay, so working in the opposite direction, f of 1/3 x. F of x is defined as the greatest integer. 1/3 x is where the x input value lies. So we are going to see a horizontal stretch. The given b value is 1/3. Its reciprocal is 3. 3 is greater than 1, so we have a horizontal stretch. What we're doing is we're starting at 0, 0, and stretching our step out 3 units. Still going up 1 unit because A is 1, but our step length is going to be 3 units long. That's the effect that the horizontal stretch has. Okay, so we've seen translations. We've seen stretches and compressions. And now we get to look at reflections. Okay, the first one, we're on the very last row, that third row. There's a negative on the outside of the brackets, which means that this is negative A, which means that we have a vertical reflection. Now, if I vertically reflect, I am flipping over the x-axis. I'm going upside down. My y values are changing, okay? Every a value affects your y values, affects your range elements. So I'm still starting at 0, 0. I'm still extending out 1 unit because my my b and my A are 1. I go down though, because instead of down to up, I vertically reflect. I reflect across the x-axis. The y values, and this part you might want to write down in the chart we just filled out on the previous page, the y values are changing their sign. Okay, for a vertical reflection, the y values change their sign. Well, if we look at the next example, it's the greatest integer of negative x. So the negative's on the inside. The negative is next to the x. This is a horizontal reflection. If you are a horizontal reflection, you reflect across the y-axis, the x values change their sign. You might want to write that down. The x values change their sign. So I'm still at 0, 0, but instead of extending to the right, I extend to the left because my x values changed their sign. If I was once positive, I am now negative. And I am reflecting, so I decrease from left to right. Does not look like an open circle. There we go. Okay, so again, if I am a horizontal reflection, the x values are affected. The x values change their sign. So not only do I decrease now from left to right, but I am a closed circle extending to the left. Everything is flipping over horizontally. I'm telling you, these transformations are so nice to see with the greatest integer function. All right, our last 2 examples, we're putting it all together, ladies and gentlemen. So write the function notation with me, please. 2 times the greatest integer of x plus 1. Okay, I see an a value that is greater than 1, so that means I'm going to have a vertical stretch. For this step function, that means that we are stepping higher to the next step. And then I have a 1 on the outside, so we go 1 unit up. Instead of 0, 0, we have a k value. I'm going to start at 0, 1. I'm going to extend out 1 unit because b is 1. And then I'm going to go up 2 units because our a is 2. And I'm going to work backwards as well. so that I can fill in a little bit more of this graph. Hopefully we're getting a little bit more comfortable with the transformation language. And if we are, that means we're ready for the grand finale. Dun, dun, dun. All right, we have a 3 on the outside. So 3 times the greatest integer of a negative 1/2 x, whoo-wee, minus 2. Here we go. There's an A on the outside. So that means we have a vertical stretch. That means we are jumping 3 units from one step to the next. Okay. B is a negative. Yeah. So horizontal reflection. And it's not just -1, it's -1/2. So the negative is a horizontal reflection. The 1/2 implies to take the reciprocal that we are now 2. We are a horizontal stretch of 2, which is the step length. And then there's a -2 on the outside, which means we go 2 units down. Okay. We always need to have a starting point. So instead of 0, 0, we shift down 2 units, closed circle. Our B value is a -1/2 in the equation. So that means I'm extending 2 units out, take the reciprocal, and due to that horizontal reflection, I'm going to extend to the left 2 units. Also, A is 3. So I'm going down because I have a horizontal reflection. 1, 2, 3 units, open circle, extend out 2 to the closed. 1, 2, 3 units down, open circle, extend out to the closed. 2, 3, and I'm working backwards. 2, 3. 1 more. There we go. Oopsies. And that is our quick little review of transformations before we get to graphing quadratics. Nice job, guys.